Good afternoon, everyone. I'm Zhiwei Liu. Next, I will introduce our work, Constable Emo LLM, the large language model for conspiracy theory detection. Our team members are from the National Center for Text Mining and School of Arts, Language and Cultures. First, I will briefly introduce our motivation. Misinformation has become one of the major threats to society. The rise of social media and the internet has made it easy to spread misinformation. Conspiracy theories are one type of misinformation whose false content is intended to cause harm. During the pandemic, the spread of conspiracy theories significantly increased. And result in a larger impact on the society. Therefore, there is an increasing urgency for high-performance methods for automatically detect conspiracy theory detections. Misinformation often conveys specific sentiments or emotions to encourage reshares. There are many studies have shown there is a close relationship between effective information and misinformation. However, the current methods to conspiracy theory detection only focus on the simple binary classification and fail to account for the important relationship between effective information and the conspiracy theories. So in this paper, we propose Constable Emo LLM, the first large language model for diverse conspiracy detection tasks using effective information. Next, I will briefly introduce how to get Constable Emo LLM. We first construct an instruction tuning dataset based on two existing datasets and define 5 tasks. The first dataset is COCO dataset. In the dataset, each text is assigned 12 conspiracy theory topic label, and each label has 3 values: unrelated, related, and conspiracy. Unrelated means that the text is unrelated to the specific category. It contains the conspiracy-related keywords, but it is used in completely different context. The related means that the text is related to the specific category, but it does not propagate the misinformation. The conspiracy value means that the text is related to the category and aims to spread the conspiracy. Additionally, in COCO dataset, each text is also assigned an overall intention label. The overall conspiracy intention label means is assigned to the text for which the conspiracy value is assigned to at least one of the 12 categories. Otherwise, if the related value is assigned to at least one of the 12 categories, the overall intention label will be related. The overall unrelated label only be used for the texts that belong to these 12 categories. This is about the first dataset. The second dataset is the local annotation dataset. It involves 2 different topics: the Sandy Hook school shooting and the coronavirus. There are 2 types of labels. The first type of label is concerned one document, whether or not one document is concerned with the conspiracy. The second type of label reflects the degree of relatedness for one document to a conspiracy. So we define 5 tasks based on the 2 existing datasets. The first 3 tasks are based on COCO dataset. Task 1 is the conspiracy intention detection. Task 2 is the conspiracy theory topics detection. Task 3 is the combination of task 1 and task 2. Task 4 and task 5 are based on local dataset. Task 4 is the traditional symbol binary classification task. Task 5 is the relatedness detection. After collecting the original dataset, we conduct effective analysis on this dataset. affective analysis is typically divided into sentiment analysis and emotion detection. Sentiment analysis includes quality detection and strength detection. Emotion detection includes classification and intensity detection. We conduct affective analysis based on our previous work, EmoLlama, which can provide 5 different types of affective information, including sentiment classification, sentiment intensity, emotion classification, emotion intensity, and emotion intensity classification. This slide shows some specific examples how to use EmoLlama. For example, for the emotion intensity task, give it text and emotion. The EmoLlama can predict the emotion intensity according to the text. And for the sentiment classification task, give it a text, the EmoLlama can predict assign it one of the 7 classes from very positive to very negative. Here we show some affective analysis results in this slide. The blue line is the twist and related to conspiracy. The green and orange line are the twists refers to conspiracy theory. From this figure file shows the quantitative analysis of emotion intensity. From the figure, we can see the twist refers to conspiracy, express stronger feelings of anger, fear, and less joy compared to the unrelated twist. While the intensity of sadness is similar across the 3 categories, indicating during the pandemic, people were generally in the state of sadness. The same conclusion is also drawn in Figure 6, which presents the qualitative analysis of emotion intensity. Figure 7 also shows the similar results. The twist refers to conspiracy show more negative emotions like anger, disgust, fear, while the unrelated twist show more positive emotions like joy, love, and optimism, and so on. The sentiment intensity in Figure 8 and the sentiment classification in Figure 9 also show the unrelated twist show stronger positive sentiment compared to the twist refers to conspiracy theory. We also conduct more effective analysis on other tasks. You can find the details in our paper. All the results show that there is a close relationship between effective information and the conspiracy theories. The effective information can be used as important features to detect the conspiracy theory. This slide shows some specific example. You can see the conspiracy and the related content indeed express stronger of anger, fear, and less joy, and show more negative sentiments. After effective analysis, we construct the instruction tuning data based on the following template. The task prompt is the task description for each task. Table 2 shows the specific example. The input text is from the raw data. The output is from the large language model. To evaluate the Constable Emo LLM, we select 20% of the data set as the validation site and 20% of the data set as the test site. So after constructing the instruction to the set, we built Constable Emo LLM by fine-tuned EmoLlama Type 7b using the instruction to the site, using the implicit effective information. This figure shows the overview of multitask instruction tuning of Constable Emo LLM. Through instruction fine-tuning, the Constable Emo LLM can obtain diverse conspiracy theory detection ability. Next, I will briefly analyze the performance of Constable Emo LLM. First, I will introduce the baseline methods. The first series is a pre-trained language model because the conspiracy theory detection is typically regarded as a classification task. So we selected the commonly used language model like BERT, ROBERT, and the CityBERT. CityBERT is a domain-specific model with in COVID domain. The second series is the large language model. Large language models have shown excellent performance on various tasks. So we perform zero-shot prompting to the following large language models, including the ChatGPT. Additionally, we also fine-tuned a model Constable LLM using the same instruction to data without using the effective information. Since all tasks are classification tasks, we use accuracy, recall, and precision and FS score to evaluate them. This slide only shows the FS score. From the table, we can see the fine-tuned Constable LLM and the Constable Emo LLM outperform all other open source language model and the ChatGPT and the pre-trained language model. And furthermore, the Constable Emo LLM achieved FS score of over 3% than Constable LLM, and except for task 3, in which it lags slightly behind the Constable LLM. All these results show the effectiveness of using effective information. Last, I will briefly introduce the usage of Constable Emo LLM. Users can easily write the prompts according to this template and use Constable Emo LLM to detect the conspiracy theories. Constable Emo LLM is open source and free. You can find this work in the following links. And this is way I first roughly introduce our motivation and introduce how to use Constable Emo LLM. Next, I analyze the performance of Constable Emo LLM. Finally, I introduce the usage of Constable Emo LLM. That's all. Thank you.
So we have time for a few questions. If anybody would like to post some questions on the back of the presentation. Yeah.
Hi, thank you for the presentation. Can you tell us a bit more about the evaluation of your approach? What kind of tasks did you give? Did you define? Because you had a number of tasks. Yeah. And how did you assess performance? How did you come up with that?
You mean how to guide?
Yeah, and you had this comparative table with some tasks.
Yeah.
Yeah. So what kind of tasks? You have in your columns. You have a number of tasks.
Yeah.
Can you give us some examples of what you said?
Example?
Yeah, in your comparative table.
Yeah, of the 5 tasks. So there were 5 tasks, 1 to 5, that you carried out using the different LLMs, right? To compare. Yes. Yeah, so what kind of tasks were they?
I introduced it. I defined this file tasks. The first is conspiracy intention detection, determine the overall intention of the tweets toward the COVID conspiracy theories. I briefly introduced the Cocoa site has 3 overall label. Unrelated, related, conspiracy. The unrelated means that the text is unrelated to all these 12 categories.
So did you have human assessors to label the different tweets, or did you automate the process of annotation? Did you have human assessors in order to, for example, to capture the intention of the tweet, or did you automate that?
The specific example.
Yeah.
Sorry, I don't. this is the specific text.
Yeah.
Yeah, and this is the specific fine-tuned data set. We first write the task description and give this model the original text. I got to show that the specific text, and then this is the class, and also give its label, and use this complete example to fine-tune the large language model. Then after fine-tuning, the large language model can perform diverse conspiracy theory detection. This is the specific example. When people only give this text and finally let the model predict the class, then the model can give the final class. Yeah, this is a specific process.
And what was the role of the human in that process? Yeah. Was there a human aspect to the analysis, or was the entire process automated?
Yeah, the users only need to write this is the prompt according to this template. The task prompt, this is the task description of the failed tasks. And then users only give the input text and select each text they want to Constable email LLM perform. Then they can get the results.
Okay. We had another question at the back first, I think.
Thank you.
Yeah.
That's really interesting research. I wonder whether or not the remit of the research actually would have allowed you to consider the practical application of both optimizing and detecting social engineering attacks, such as business email compromise, for example. If you're able to trigger through those emails more of an emotional response and drive short-term behaviors from a victim, or also actually, as a defender, identify through the use of this research, more easily identify potential email attacks for social engineering. I wonder if that was a part of the considerations.
You mean can we use Constable email LLM to detect email context?
Yeah, or even design them more effectively. Right? So you're always playing both sides of that particular
a tool for criminals, in other words.
Yeah, I mean, obviously, in the real world we don't do that, but actually, if you can model that, then you can identify what's a more effective attack and then design more effective defenses against that attack.
Yeah, yes, I can. I think Constable email LLM can be used to detect different types of text. But we need to enlarge the training data set to perform better on the text. No, we only fine-tune the large language model on the failed tasks. So if we want to let the Constable email perform better, we need to collect more data, like the email text you mentioned, and to enhance the Constable email. Thank you.
Good. We have time for one last question. Mustafa, can you raise your hand?
Yeah. So if you go back to your table with the results, so it seems that for task 2, like all the tools, including yours, that you're not doing well. Can you
yes.
give us some intuition, like what?
Yeah, because task 2 is a 12 class classification task. Is more difficult than other tasks. So we can say the Constable LLM perform all models perform lower in task 2. Although task 3 is a combination of task 1 and task 3, we split the task into fine-grained data items. Got to split one into 12 items. So we can say all models perform better in task 3.
Great, thank you. I think we better leave the discussion there, and then we can continue afterwards in the networking event. We'll move on to the next presentation.